Dear viewers of my YouTube channel Dr. C. Ganesh Teaching Modules, this is my third module in Success to Gate Control Systems. In the last module, I have explained the solutions to gate questions from different disciplines, where questions are asked in time response analysis. In this presentation also, I will solve more questions from time response analysis. Question number 1. So this question has been asked in GATE 2019 Instrumentation Engineering, question number 46. The transfer function relating input x of t to the output y of t of a system is given by g of s equal to 1 by s plus 3. A unit step input is applied to the system at time t equal to 0. Assuming that y of 0 equal to 3, the value of y of t at time t is equal to 1 is dash. Answer should be rounded off to 2 decimal places. So this is a problem in which the initial output is specified. Since initial output is specified, we cannot take the transfer function as it is with 0 initial conditions. Therefore, from the transfer function given, we should take the differential equation governing the dynamic behavior of the system. From the differential equation, we have to substitute the initial condition by taking again the Laplace transformation. So that is what I have done here. So the initial output y of 0 is specified as 3. The transfer function is 1 by s plus 3, that is the y of s by x of s. Therefore, by cross multiplying this, we can write s plus 3 into y of s equal to x of s. Therefore, this should have come from the time domain equation. S into y of s means dy by dt. 3y of s means 3y of t. X of s means x of t. So this is a differential equation describing the dynamic behavior of the system. So this is the mathematical model of the system given. So taking Laplace transformation on both sides of the above equation, but not assuming 0 initial conditions, because initial condition is given, y of 0 is 3. So dy by dt on Laplace transform, s into y of s minus y of 0. So 3y on Laplace transform 3y of s, x of t on Laplace transform x of s. So substituting this y of 0 as 3, simply substitute here. So we get this. So this is s plus 3 into y of s equal to x of s plus 3 after simplifying. Then this can be further written by substituting x of s as 1 by s at time t equal to 0, because unit step input is applied at time t equal to 0. Therefore x of s is 1 by s, because Laplace transformation of 1 is 1 by s. So substituting this for x of s in the above equation, that is in this equation, wherever x of s I replace with 1 by s. So we get this. Therefore y of s is 1 by s into s plus 3 plus 3 by s plus 3, that is dividing throughout by s plus 3. So by partial fractioning, this can be partial fractioned as 1 by 3s minus 1 by 3 into 1 by s plus 3 plus 3 by s plus 3. So by inverse Laplace transformation, we get y of t equal to 1 by 3. 1 by 3, 1 by s is 1 by s inverse Laplace transformation is 1. So 1 by 3. So minus 1 by 3. 1 by s plus 3 is e power minus 3t. Here again 3 into e power minus 3t. So the question asked is, we have to find out y at time t is equal to 1. So if we substitute t is equal to 1, we get 0.47. So this is the output. Anyway, we can even cross check whether we have found it correctly. If we substitute t equal to 0, what happens is, this is minus plus 1. So 1 by 3 minus 1 by 3 is 0. So 3 into 1 is 3. So we get y of 0 as 3. That is, the initial condition is satisfied. Therefore, in that way also we can check whether we have solved the equation correctly. So after solving, substitute and find out. Since we are asked to find out the output corrected to 2 decimal places, it is 0.47. Next problem. This problem has been taken from GATE 2019 Electrical Engineering, question number 1. This is actually normal problem in signals. That is inverse Laplace transformation of h of s equal to s plus 3 by s square plus 2s plus 1 for t greater than or equal to 0. They have given the options. Since it is a second order system, I have taken this also for consideration in this particular video. So this is s plus 3 by s square plus 2s plus 1. So the s square plus 2s plus 1 can be factorized as s plus 1 whole square. So by partial fractioning, we can get this as 2 by s plus 1 whole square plus 1 by s plus 1. So by inverse Laplace transformation, this impulse response h of t is equal to, so this is 1 by s plus 1 whole square. Normally 1 by s square means t. 1 by s plus 1 whole square means first shifting principle. That is, multiplying a function e power minus t is equal to replacing s with s plus 1. E power minus at means s by s plus a in s domain. So here 2 into 1 by s plus 1 whole square. So 1 by s square means t. 1 by s plus 1 whole square means, that means s is replaced with s plus 1. Therefore, it should be multiplied by e power minus t. So 2t e power minus t. This we know very well, it is e power minus t for t greater than or equal to 0. So this fits into option C. Therefore, option C is correct. So problem number 3. This is again taken from the same question paper. GATE 2019 Electrical Engineering. But this appears as question number 13. Output response of a system is denoted as y of t and its Laplace transform is given by, so it is again a second order Laplace transform. So the steady state value of y of t is, they have given the options. So the response is given with respect to the input also. It is very well known that it is step input because it is multiplied by s. So we are asked to find out the steady state value of y of t. So steady state means better go for initial final value theorem. So according to final value theorem, I want final value of y of t. So limit t tends to infinity, y of t is limit sn into 0, s times y of s. So y of s is there, it is substituted. So s cancels. So s square 0, 0. So 10 by 100 root 2. So 10, 100, if you cancel 1, 10. So 1 by 10 root 2. So option A is correct. Next problem, it is taken from GATE 2019 Electronics Engineering Set 1, question number 5. Let y of s be the unit step response of a causal system having a transfer function g of s equal to 3 minus s by s plus 1 into s plus 3. That is, y of s equal to g of s by s. The forced response of the system is, so 4 options are given. Causal system, we know causal means output at any time depends on only the present value of the input. That means y depends on input at time t, that's all. So it is not shifted time. That is, past value of the input or past value of the output will not decide the present value of the output. So output depends only on the present input. That's the output at that particular time. That is what we normally do. So we normally take that as causal system only. Right. So forced response of the system we are asked. So y of s is g of s by s. That means indirectly they say it is step response means 1 by s into g. That's all. So even if it is not given, anyway we are going to take unit step response means y of s by multiplied by that only we are going to take. Okay. So g of s is there, that is multiplied by 1 by s. So partial fractioning, we get 1 by s minus 2 by s plus 1 plus 1 by s plus 3. So if we take inverse Laplace transformation, so inverse Laplace transformation of 1 by s is actually 1 t greater than or equal to 0. If we don't want to write t greater than or equal to 0, we can write e of t. So minus 2 by s plus 1, so minus 2 e power minus t. We are extra writing u of t because t greater than or equal to 0 is automatically implied by u of t, because u of t is equal to 1 when t greater than or equal to 0, equal to 0 when t less than 0. This we know very well. So 1 by s plus 3 inverse Laplace transformation e power minus 3t u of t. So this fits into first option. So option A is correct. Last problem. This is again taken from 2019 Electronics Engineering GATE question paper, set 1, question number 31. So last one was question number 5. This is 31. So they have given a causal second order system with a transfer function. They have said unit step input 1 by s, c of s the corresponding output, time taken by the system output c of t to reach 94% of steady state value, rounded off to two decimal places. So rounded off to decimal places. They have given two decimal places. So 5.25, 4.5, 3.89, 2.89. So transfer function is given, input is given. So input multiplied by the transfer function is the output in S domain. So that we have written. This is s square plus 2s plus 1, therefore s plus 1 whole square. Like the problem that we have done here, we have to do the partial fraction. Same s plus 1 whole square we get. So in the same way we have to do the partial fraction. So 1 by s into s plus 1 whole square means 1 by s minus 1 by s plus 1 minus 1 by s plus 1 whole square. So by taking inverse Laplace transformation, 1 by s means 1, 1 by s plus 1 means e power minus t. This is again first shifting principle. So t into e power minus t. Therefore, if we take that e power minus t common to second and third terms, 1 minus e power minus t into 1 plus t, t greater than or equal to 0. So steady state value of output we have to find out. So if we substitute t is equal to infinity, e power minus infinity is 0. So 0 multiplied with this is 0. So 1 minus 0, 1. That means steady state value is 1. The question is time taken by the system response to reach 94% of steady state value. That means this particular response E of t, how much time it takes to reach 0.94. Therefore, we have to equate this to 0.94. That is what I have written here. So we can solve this. Actually, we can take logarithm, all that. Instead, options are given. So best thing is substitute the options, then check whether the right hand side is satisfied. So it is found that when we substitute t is equal to 4.5, here right hand side is satisfied. Therefore option B is correct. So in this presentation I have solved only 5 questions from GATE 2019. Anyway, we have lot of questions in GATE from time response analysis. So I don't want to combine all the problems into one video. So I will include the problems stage by stage. And as I have already committed, I will solve the problems from different disciplines. That is not only electrical engineering, electronics engineering, that is electronics and communication engineering, instrumentation engineering, chemical engineering. If any question has come from that particular time response analysis in these disciplines in the last 5 years, I will take that and solve. That is how I have been doing in the 3 videos. So I will continue that in the next video also. So for the benefit of the learners, viewers, I have given which problem, which video can be referred to understand the basic concepts in detail, because some of you may directly see this video without seeing my earlier videos. So to facilitate those people to capture the information that is for detailed study and revision of topics, I have given this table. So which problem, which video can be referred for detailed study or revision, what is the URL of the video. So this is my URL of the channel, Dr. C. Ganesh Teaching Modules. So I have been doing this exercise, that is presentation of my lecture through different videos. So I will continue that for some more time. So I need your support, encouragement and motivation and valuable feedback so that I can still do better presentation in the future videos. So I thank you very much for every one of you for viewing my videos, sharing my videos and subscribing my videos. I'm sure that I'll be able to do still better presentation in my future videos.